Problem 560. In problem 556, you looked at the inverse of y equals 3 to the power of x. Finish investigating this function. Now, just to make sure we're emphasizing here, we're looking to finish investigating the inverse of y equals 3 to the x. So if we think about y equals 3 to the power of x, the inverse here is going to be the equation x equals 3 to the power of y. So we're looking to investigate this function here. Now we can use what we know from this one in case you were absent or you didn't start working on it in class. We can take our y equals 3 to the power of x, and we could create a little t-chart there. And we've got our inputs and our outputs. So when we plug in some different values here for x, let's plug in a couple negatives. Let's say -2, -1, 0, 1, 2, 3. The more points we have, the better. So when we take -2 and we plug it in here, we should get 1/9. Plug in -1, we should get 1/3. Plug in 0 for x, you should get 1, then 3, then 9, then 27. So simply plugging in the input for my x value in this exponential function. This is an exponential function here, and we're getting our outputs there. So let's look at the inverse function. We should have a pretty comfortable understanding now that when we take two functions and we are looking at their tables, the inverse is simply going to flip-flop our x and y values. So if 1/9 was our input, -2 would have been our output, and so on there. So I'm going to go ahead and just get those copied down. I'm just flip-flopping the orders here. And last one there. And you'll see here I made a little mistake. I did not flip-flop those two, so I need to go back and fix that there. This should be changed to, this would be -1. This would be 1/3. And you see how easy it is to make that mistake, so make sure you're careful when you're doing that. Just double check that you recopied them down. So if we take these and let's plot these points on here. So when x is 1/9, y was -2. So when x is 1/9, it's really close to 0, and we're going down 2. When x is 1/3, y was -1. We've got 1, 0, 3, 1, 9, 2, and then obviously 27, 3 would be way down the line here. So what we're looking at here is a function that is right along. Oops, let's undo that. It's kind of hard to draw with this, so let's just start up here. And it curves out this direction. So and then it should continue on down, not actually touching our y-axis there, but it should come up and curve out this way. Now, to finish investigating here, some of the things we need to look at is, what is the domain? What is our range? Special points, is there an x-intercept? Is there a y-intercept? And are there any asymptotes? So as we look at this here, our domain, you'll see here that it's just going to creep right along the y-axis until it comes up, and then it curves out and goes this direction. So if we took it here, there is no number that we could raise 3 to, or no power, to get a 0 as our x value here. So we can say that x has got to be greater than 0. Our range, well, this one's going down forever, and then it comes up and it curves upward forever, so we're going to look at all real numbers. So you could say negative infinity is less than y, which is less than positive infinity, are all real numbers, because it's going to extend upward and downward forever in both directions. Oops, let's get rid of that. Our x-intercept, well, it does intersect the x-axis right here. That should be the point 1, 0. And it's going to get closer and closer and closer to the y-axis, but it will never actually touch it. So we're going to say that there is none in this case. And then are there any asymptotes? Well, we see it's going downward this way, and it's going to get closer and closer and closer to the y-axis, but not ever actually touch that axis. And then it comes up and goes gradually up and right to, forever there. So there is that imaginary boundary line here that runs right along our graph. That would be the graph of x equals 0, because it's never going to touch this line here as it goes down. Pretty much that should be it for 5-60. We were just finishing exploring the inverse of y equals 3 to the power of x. So remember, this is our exponential function. The inverse, we just flip-flop our x's and y's, flip-flop our points in the table there, and then plotted them on here to see what it looked like. This would have been a direct reflection over the line y equals x, which would have been, our regular function that we were starting with, our exponential function, y equals 3 to the x. If you have questions about this, make sure you ask your teacher. This is one that can be a little bit more difficult till you get the hang of it, but if you stick with it, it will get easier. Thanks for listening.